I'm making a very short supplementary video, I hope it's short, to explain something that apparently puzzled a few people. But let me first begin by saying that I really love people who ask questions when they're puzzled, because believe me, I've asked a lot of questions in my day that I thought were super simple, but fortunately the better mentors always were patient enough to explain. They never said that's a stupid question. They always said, well, that's a good question. So the question that's being asked has to do with outside foil, and it's a good question. I pointed out in the video on Frugal Repairman capacitors that back in the day, one end of the foil capacitors was marked with, and I don't know if you can see it, but there is actually a black band on this end, and there's not one on the other end. That is called the outside foil, and we'll talk about that a little more. Here's another one. Notice in this case it's a red band, but that's because the body is black. So there's a band on that end, but not on this end. That's the outside foil end. They always the end with the band. So what I thought I might do, because some people have been puzzled about what does outside foil really mean, so I thought we'd just go ahead and build a capacitor. So down here is a little construction. This is a piece of foil with a wire. I just taped it there. Now normally back in the day the wire would actually be attached to the foil by various means like sintering or soldering or whatever, but I'm just going to tape it. Then there's a piece of waxed paper, and then on the other side is another piece of foil with a wire attached to it. Now watch what happens as we begin to roll this up. You see, one of those foils winds up on the inside, and one winds up on the outside. Pardon my inexpert winding ability here. But eventually, you see, each time as you wind, the foil on this side is on the outside, and so and that is this wire. So when we get all done, what we would do is mark this end of the capacitor with the band. So let's unwind that and see why. You see that this one, that is the wire that's coming out to the right, is always on the inside because of the way we chose to roll it. Now, if we'd have wound the capacitor the other way, then the right-hand side would have been the outside foil, because then we would have this situation. Okay, and if we wound it this way, then this would be the inside foil, and the one that is outside would be this other lead. That's what they mean by outside foil. Now, let's take a look at what we mean by bypass and coupling. And here is a schematic from the radio that we've been working with, that Watterson radio. You notice that there is a C13 capacitor right there, and there is a C15 capacitor here. The symbol down here means ground. That just means the common tie point. It's usually the chassis, but it may not be. It can just be the place that everything is tied to. So this is connected to that point. They use this ground symbol as an expedient, but you could literally draw the schematic with all these points tied together with just one wire that kind of went all over the place. This is just to save the confusion of having all those overlapping wires that all connect to the same place. So normally this is the chassis. And it is normally the point that you bypass all of the AC signals that you don't want. So, for example, the capacitor from this point to ground is a bypass capacitor. It's designed to remove certain AC from this line, alternating current. Now, of course, it doesn't pass DC. In this particular case, this isn't designed to remove all the AC because you want some of it to couple through this capacitor to the grid of the next circuit. And that's why this is called a coupling capacitor. So a capacitor from a point to ground is usually a bypass capacitor, and a capacitor from the plate of one section to the following grid of another is a coupling capacitor. Normally, you would connect the outside foil to the ground end. So with C15, you would want the outside foil to be at the bottom. It makes less difference, but you normally would connect the outside foil to the plate of the preceding tube. Remember, these two, the foil has nothing to do with voltage or rating or anything. It just has to do with physical location. So if you use this end of the capacitor connected to the plate, and that is the outside foil end, then it sort of shields the next plate. Just as if you think about the bypass capacitor, think of it as a shield that is coming up and around the inside foil. So I hope that helps explain inside foil, outside foil, bypass, and coupling. And once again, I'm trying to make this, I'm trying to remember that once upon a time, I asked these same questions. So please don't feel that the questions you ask are too simple. When you're first starting out, that's the big problem. There's so much going on that you're accumulating stuff, and maybe 5% of what is said you understand, and then the next time 10%, and so on. Just stick with it. Someday you'll know enough to be able to teach some other people. So I hope that this has been useful and enjoyable, but more important, stay tuned for some more, and please have a nice day.